Look up at the night sky for a moment. Every star you see belongs to a galaxy, and almost every galaxy in the universe is spinning. Massive cosmic structures containing hundreds of billions of stars slowly rotating through space, like gigantic celestial pinwheels. Some of these rotations take hundreds of millions of years to complete. But here's the strange part. Why do they spin at all? Why didn't matter in the universe simply collapse into random clumps? Why do planets rotate? Why do stars spin? And why do entire galaxies turn across the darkness of space? Even more mysterious, this pattern of rotation appears everywhere. From hurricanes on Earth, to forming planets, to the largest structures in the cosmos. It's almost as if the universe itself prefers to move in spirals. So in this video, we're going to travel across an extraordinary range of scales, from the smallest particles of matter, to planets, to stars, and finally to the spinning galaxies that fill the universe. And by the end, you may realize something astonishing. You are not standing still. You are living on a spinning planet, orbiting a spinning star, inside a spinning galaxy, in a universe where motion never truly stops. When astronomers point their telescopes toward the night sky, a striking pattern keeps appearing. Across billions of light years, galaxies are not still clouds of stars. They are rotating. Slowly, majestically, these enormous islands of light turn through space. And that simple observation raises a profound cosmic question. A galaxy can contain hundreds of billions of stars, along with gas, dust, and dark matter. Yet instead of drifting aimlessly, much of that material organizes into elegant spirals. These spirals sweep outward like giant pinwheels in the darkness of space. Some rotate so slowly that a single turn can take hundreds of millions of years. Seen from afar, a spiral galaxy almost resembles a cosmic hurricane. Its arms curve gracefully around a glowing center, stars flowing like luminous currents. Everything appears to be moving together in a vast coordinated rotation. But why would something so enormous begin spinning in the first place? Gravity explains why matter clumps together, pulling gas and dust into dense regions. But gravity alone doesn't demand that those clumps rotate. In principle, matter could simply collapse inward from every direction. So where does this universal tendency to spin actually come from? That question becomes even more intriguing when astronomers widen their view. Galaxies are not the only things that rotate in the universe. In fact, spin seems to appear almost everywhere scientists look. And once that pattern becomes visible, a much bigger mystery begins to unfold. Once scientists noticed galaxies spinning, they began to see a much larger pattern. Rotation wasn't limited to distant star systems or exotic corners of space. It appeared again and again across vastly different scales of the universe, almost as if spinning were one of nature's favorite ways to organize motion. Take a look at our own solar system. Every planet rotates on its axis while also orbiting the sun. Jupiter spins so quickly that a full day there lasts only about 10 hours. Even the sun itself slowly turns, carrying storms and magnetic fields along its surface. Back on Earth, rotation shows up in familiar ways. Hurricanes swirl across oceans, forming gigantic spinning storms visible from space. Water draining in a sink creates tiny whirlpools that mirror the same pattern. From small spirals to massive atmospheric systems, motion often curves instead of moving straight. Astronomers also observe rotation inside enormous clouds of gas floating between the stars. These clouds twist and swirl as gravity pulls their material inward. Over time, these gentle motions can grow stronger and more organized. What begins as a faint drift eventually becomes a clear rotating structure. The strange part is how universal this pattern seems to be. From storms on Earth to spinning stars and entire galaxies, rotation keeps reappearing. It's almost as if the universe naturally prefers motion that curves and spirals. But to understand why that happens, the story must go much deeper, all the way down to the smallest building blocks of matter. To understand why the universe loves rotation, scientists sometimes look in the opposite direction, toward the smallest scales imaginable. Long before galaxies existed, the building blocks of matter were already in motion. Atoms, particles, and tiny interactions were constantly exchanging energy and momentum. Even in this microscopic world, stillness is surprisingly rare. Inside every atom, electrons move around the nucleus in energetic patterns. They don't orbit exactly like planets around a star, but the image is still helpful. Imagine tiny charged particles buzzing in structured motion around a central point. Even at this scale, nature seems comfortable with circular and spinning behavior. Particles themselves also carry something physicists call angular momentum. This property acts a bit like intrinsic spin, built into the particle itself. It's not exactly like a spinning ball, yet the mathematics describes rotation-like behavior. In other words, motion that resembles spinning appears deep within the rules of physics. During interactions between particles, even the smallest imbalance can matter. If energy moves slightly more in one direction than another, motion begins to curve. Those tiny asymmetries introduce rotation into systems of matter, and once rotation begins, the laws of physics tend to preserve it. So even before planets or stars form, the seeds of spinning motion may already exist. Matter isn't perfectly symmetrical or perfectly still as it gathers together. Instead, small motions build upon one another like gentle ripples growing into waves. And when gravity starts pulling matter into planets, those tiny beginnings suddenly become much more dramatic. Now the story begins to scale up from particles to worlds. Across space, enormous clouds of gas and dust drift quietly between the stars. These clouds may appear calm, but inside them, gravity is constantly pulling material inward. Slowly, gently, regions begin collapsing to form new planets. At first, the motion inside these clouds is incredibly subtle. Tiny currents of gas drift past each other like slow-moving rivers in space. But even the slightest sideways movement matters once gravity starts pulling things together. As the cloud shrinks, that small motion begins to grow stronger. A simple way to imagine this is by watching a spinning ice skater. When a skater pulls their arms inward, their spin suddenly speeds up. The same thing happens when a cloud of gas collapses into a forming planet. As the material contracts, its rotation becomes faster and more defined. Over time, that spinning mass begins shaping the newborn world. The rotation flattens the surrounding disk of dust and gas. Material gathers into rings and clumps that eventually become moons, asteroids, or neighboring planets. Bit by bit, an entire planetary system begins to take form, and once a planet starts spinning, it rarely stops. The motion can continue for billions of years unless powerful forces slow it down. That's why nearly every planet in our solar system rotates today. But surprisingly, this spinning motion isn't just a cosmic coincidence. It's governed by one of the most important laws in physics. Rotation isn't just a distant cosmic curiosity. It's something engineers and astronauts must deal with every time humanity reaches for space. Every spacecraft launched from Earth enters an environment where spinning motion matters. Without understanding rotation, space exploration would be nearly impossible. Satellites, for example, constantly rely on rotation to stay stable. Inside, many spacecraft are spinning devices called gyroscopes. A gyroscope behaves a bit like a perfectly balanced spinning top. Once it's rotating, it naturally resists changes in direction. This stability becomes incredibly useful in space. Satellites use gyroscopes to maintain orientation while orbiting Earth. Even small adjustments in spin help spacecraft aim antennas, cameras, and solar panels. Without these systems, satellites could slowly tumble out of control. Astronauts also encounter rotation in fascinating ways. In orbit, even a gentle push can send a person slowly spinning through the cabin. Without gravity pulling them down, motion keeps going almost indefinitely. The smallest twist of the body can turn into a graceful floating rotation. Scientists have even explored using rotation to create artificial gravity. If a space station spins fast enough, the outward force can press astronauts toward the walls. It's similar to how riders feel pushed outward on a spinning carnival ride. And understanding why this works leads directly to one of the most powerful laws governing motion in the entire universe. Behind the spinning of planets, stars, and galaxies lies one of the most powerful rules in physics. It's called the conservation of angular momentum. The idea is surprisingly simple. Once something begins rotating, it naturally wants to keep rotating. Unless an outside force interferes, that spin tends to persist. A familiar example appears in a child's spinning top. Once set in motion, the toy keeps turning smoothly on its tip. It may wobble slightly, but the rotation continues until friction eventually slows it down. In the vacuum of space, however, there's almost no friction to stop the motion. That's why rotation can last for billions of years in the cosmos. When a cloud of gas begins turning even slightly, gravity pulls the material inward. As the cloud shrinks, The same amount of angular momentum is packed into a smaller space, and just like the ice skater pulling in their arms, the spin speeds up dramatically. This law governs motion on scales both tiny and enormous. It shapes the way stars form, the way planets rotate, and the way galaxies organize themselves. Even swirling storms on Earth follow the same physical principle. Nature seems to reuse this elegant rule everywhere motion occurs. So when astronomers observe a spinning galaxy, they're seeing angular momentum preserved across unimaginable scales. A faint motion that began long ago continues today, carried through cosmic time. But to truly see how powerful this process can be, we need to travel back billions of years, to the moment our own solar system first began to form. About 4.6 billion years ago, our solar system didn't exist yet. Instead, there was a vast cloud of gas and dust drifting quietly through space. Astronomers call this type of structure a molecular cloud, a cold and enormous nursery of future stars. At first glance, it may have looked calm, but subtle motions were already stirring inside. Over time, gravity began pulling parts of this cloud inward. Regions slightly denser than their surroundings started collapsing under their own weight. As the material gathered, the cloud didn't simply fall straight toward the center. Even the tiniest sideways motions began to influence how the collapse unfolded. As the cloud shrank, those small motions grew stronger. Just like a figure skater pulling their arms inward to spin faster, the collapsing cloud began rotating more rapidly. The entire structure flattened into a giant spinning disk of gas and dust. Astronomers call this a protoplanetary disk. At the center of that disk, the newborn sun ignited. Around it, swirling rings of material began clumping together. These clumps gradually grew larger, forming the early building blocks of planets. Bit by bit, the rotating disk gave birth to the solar system we know today, and the spin of that ancient cloud still echoes through space today. The planets orbit the sun in the same general direction as that original disk's rotation. Moons circle their planets, and many of those planets spin on their own axes. But the consequences of that rotation go far beyond planetary motion. They shape the very rhythm of life on Earth. Right now, without feeling it, Earth is spinning beneath our feet. Our planet completes one full rotation roughly every 24 hours. That steady motion creates one of the most familiar rhythms of life, day and night. Sunlight sweeps across the surface as the planet slowly turns through space. Imagine if Earth suddenly stopped rotating. One side of the planet would face the sun constantly, becoming unbearably hot. The other side would remain in permanent darkness, freezing in endless night. The simple act of spinning keeps temperatures balanced across the globe. Rotation also plays a powerful role in shaping our atmosphere. As Earth spins, moving air gets twisted into large, circulating patterns. These swirling motions help create trade winds, jet streams, and massive storm systems. Even hurricanes owe their spiraling structure to the planet's rotation. The oceans feel this motion as well. Currents sweep through the seas, distributing heat around the planet. Warm water moves toward colder regions, while cooler water travels elsewhere. This circulation helps stabilize Earth's climate over long periods of time. In many ways, Earth's spin quietly supports the conditions that allow life to exist. From weather systems to biological cycles, rotation shapes the environment we depend on. But our planet's motion is just one tiny example of a much larger cosmic pattern. Because when astronomers look outward again, they find entire galaxies turning through space. Now the scale of the story grows dramatically. Instead of planets and stars, imagine structures containing hundreds of billions of suns. These enormous systems are galaxies, vast cosmic cities of light spread across space. And just like planets, many of them are slowly spinning. One of the most beautiful examples is a spiral galaxy. Its stars trace enormous curved arms that wrap around a glowing central core. Seen from afar, the whole structure resembles a gigantic cosmic pinwheel. Every star inside it participates in this slow, graceful rotation. But galaxies didn't begin as organized spirals. In the early universe, matter existed in huge clouds of gas and dark matter. Gravity gradually pulled this material together into growing clumps. As these regions collapsed, tiny motions inside them began to amplify. Just like the formation of planets, the same rule applied. When a massive cloud contracts under gravity, any slight rotation becomes stronger. Over millions and billions of years, that motion organizes the galaxy's structure. Stars settle into rotating disks, forming the elegant spiral arms we observe. Yet the story becomes even more fascinating when scientists look deeper. Galaxies don't simply rotate because of their visible stars and gas. Something unseen seems to influence how fast they spin, and tracing that mystery leads astronomers even further back, to the earliest moments of the universe itself. To understand why galaxies spin, astronomers sometimes rewind the story of the universe itself. They look back nearly 13.8 billion years, to the moment shortly after the Big Bang. At that time, the universe was a hot, dense ocean of energy and particles. Matter had not yet formed stars, planets, or galaxies. But even in that early cosmic chaos, the universe wasn't perfectly uniform. Tiny fluctuations in density appeared throughout space. Some regions contained slightly more matter than others. Those small differences would eventually shape the entire large-scale structure of the cosmos. As the universe expanded and cooled, gravity began pulling matter toward these denser regions. Clouds of gas slowly gathered into growing cosmic structures. Within those collapsing regions, small motions and irregularities began to appear. Those subtle movements planted the seeds of rotation. Over millions and billions of years, these early motions became amplified. As matter continued collapsing into galaxies, angular momentum naturally emerged. The same law that spins a figure skater or a hurricane was now shaping entire galaxies. What began as tiny imbalances grew into the vast rotating systems we see today. In other words, the spinning galaxies scattered across the universe may trace their motion back to the very birth of cosmic structure. A faint whisper of motion in the early universe has echoed forward across billions of years, and that realization leads to an even more profound perspective. Because when we zoom out far enough, rotation seems woven into the very fabric of existence. By now, a remarkable pattern begins to emerge. From the tiniest particles to the largest galaxies, motion is everywhere. Nothing in the universe seems truly still for long. Instead, everything participates in an endless cosmic dance. Electrons move inside atoms. Planets spin while circling their stars. Stars orbit the centers of galaxies in enormous sweeping paths. Layer upon layer, the universe appears built from motion within motion. Even our own existence unfolds inside this spinning system. Right now, Earth is turning beneath our feet at about 1,600 kilometers per hour. At the same time, our planet is racing around the sun, and the sun itself is orbiting the center of the Milky Way. Yet from our perspective, life often feels calm and stable. We wake up, watch the sunrise, and see the stars appear at night. But behind that quiet rhythm lies a breathtaking reality. Our entire world is moving through space in a vast celestial flow. So perhaps the deeper insight is this: the universe was never meant to be static. It is a story of motion unfolding across unimaginable scales. And every spinning galaxy, every turning planet, and every orbiting star is part of the same cosmic rhythm.